We're going to be looking at rising and setting times for lunar phases. You haven't even learned about some of the lunar phases yet, but we'll be going through that as well. And so we'll move on. We'll start with a view of something that's supposed to represent Earth. This is the way that I drew it in PowerPoint. PowerPoint has limited drawing abilities, and I have limited drawing abilities, so if you multiply those two together, you get a lot less. And so that's what you get for the Earth. The yellow arrows over on the left represent the direction from which the sunlight comes. So somewhere far, far off to the left would be the sun, and we've got the Earth there. Now, Earth turns on its axis. We're taking a view from far above the North Pole, like hundreds of thousands of miles above the North Pole, and looking down there at the Earth, and the Earth would turn in a counterclockwise direction from that viewpoint, which means it is turning toward the east. And so that's what the Earth happens to be doing. Now, half of the Earth is dark, and so we'll shade it in there. Not completely dark, so we can still tell that there's an Earth there, but this will represent the nighttime side of the Earth. The side of the Earth that's away from the sun is the part that's experiencing night at any time. And as the Earth turns, when we rotate into the sunlight, we experience sunrise, and when we rotate into the dark, we experience sunset. And then while we're in the dark, we're experiencing night. And so that's the way the Earth behaves. Now let's take a look at someone standing on that Earth. And so here we have a little guy there, and to him the Earth looks flat, and we have the arrows for the sun coming in there. He would be experiencing sunrise at this time. The sun rises in the east, so in that direction is his eastern horizon. Behind him, in the opposite direction, would be his western horizon. Now, we'd like to be able to get some understanding of how this will look for someone on a curved surface, and if I drew the human to the correct scale on a curved surface, he'd be way too high, but we'll do it anyway. And so now we've got this little human standing on the curved surface of the Earth. This person, as drawn, is only a few hundred miles high, so you can imagine that anyway. And his horizon stretches out in both directions, actually in every direction. But if you imagine shrinking him down to his correct size, you could still see how that horizon leaves the surface of the Earth. The horizon goes straight out horizontally, but because the Earth curves away from it, it'll be doing something like this. You could think of the horizon as being a line tangent to the Earth, just touching it at a point where you happen to be standing. Now we'll make things even worse. Now we've got a human there who's about 3,000 miles high, and you can see his eastern and western horizon there. And as the Earth rotates, his horizon will rotate with him. So now we have the Earth turning around. The leading edge of the green arrow is his eastern horizon, and the trailing edge is his western horizon. So he's about to experience sunrise as his eastern horizon sweeps past the sun. Now he would be at the point where he is experiencing noon. The sun is high overhead. Neither his eastern or western horizon is pointing at the sun. Rotate a little farther. Now he's experiencing sunset. His western horizon is pointing at the sun and is about to sweep past the sun. Now he's experiencing night. Right now he's directly facing away from the sun, so he would be experiencing midnight or 00 hours on the 24-hour clock. Now he's about to experience sunrise again. So that's how we experience these different times. As the Earth turns, we experience different times of different amounts of sunlight. The sun moves across the sky and things like that, all because the Earth is turning on its axis. So our big ideas so far: as the Earth rotates on its axis, your local horizon rotates with it. That's part of where you happen to be on the Earth, is your local horizon. The half of the universe that's above your horizon is visible, or it would be if it wasn't cloudy or if the sun wasn't up. At night it is. As your eastern horizon sweeps past something, that's when an object rises. And as your western horizon sweeps past something, the object sets. This is a couple of lines from an old song by John Lennon and Paul McCartney, the songwriters for the Beatles. Most of the time they were the songwriters. Sometimes George Harrison wrote, but the line, "The fool on the hill sees the sun going down, and the eyes in his head see the world spinning round." And so this is about doing that. Next time you watch a sunset, see if you can get yourself away from thinking that the sun is going down and recognize that the thing you're standing on is rotating so that the sun is going to fall below your western horizon. Okay, let's make a clock. This is where a person would be standing at 6 a.m. when they're experiencing the sunrise, when their eastern horizon is pointing toward the sun. A quarter rotation later, they're experiencing noon. The sun is directly overhead. So 1200 hours. I'll give both 24-hour clock and AM PM times on this thing. Let's do another quarter rotation. Get down here, they would be experiencing sunset, which for someone standing on the equator like this person is, that would happen just about 6 p.m. or 1800 hours. We're building a clock. Another quarter revolution here, from 1800 hours forward 6 hours. You get to 24 hours, but that's where the time starts. So that's 00 hours, or 12 a.m. Another quarter rotation, and they'll be back to 600 hours. So let's just shrink the Earth down and put our clock markings on there. There's what we have. We can fill in the rest of them. Now, in each case, these represent where that person is going to be. 3 o'clock, that's where they'd be, halfway between 0 and 6 hours. We can fill in the 9 o'clock or 900 hour. 600 and 1200, halfway between is 900. The next one to fill in could be 1200 to 1800, halfway between is 1500. And then finally 2100 over there. And if you split each one of the segments we've got up here into 3, you could fill in the missing hours. But that's good enough for now, otherwise we'll get too crowded. So now let's put our observer right over here. Their eastern horizon might be pointing in some direction in space, but for them, they're at the 2100 hour mark, and they would be experiencing 9 p.m. at night. That's where you happen to be in relation to the sun at 9 p.m. at night. If you're on the equator, that is. Here's where they would be standing if they were experiencing 1200 hours, noon. At this point, they'd be experiencing 300 hours, 3 a.m. And so they've gotten past midnight. Remember, the rotation is counterclockwise. And they'll soon be experiencing sunrise, or at least in 3 hours they will be. And then down here, they're experiencing 1800 hours. Their western horizon is about to sweep past the sun, and so they'll be experiencing a sunset, or are right now. Okay, let's get the moon into this, because the whole point of this is to learn to identify phases of the moon and also to be able to determine when those phases happen to rise and set. So this is a diagram that I like to be able to draw by hand, and it would be nice for you to draw it by hand as well. And I'll show you on a piece of paper sometime just how quickly I can do this diagram. I start off by drawing a bunch of parallel lines coming from either the left or the right, representing light coming from the sun. And then I put a little circle in the middle that represents the Earth, and then I draw the moon phases here. Now, each of these things that you see around here that look like a white half circle, each of those represents that part of the moon that is facing the sun and is illuminated by the sun. The side of the moon that's facing away from the sun would appear black or dark because it is not illuminated by the sun. The lunar cycle starts with the new moon, and that is when the moon is between the Earth and the sun. From the Earth's viewpoint, when you look toward the moon at this time, you're looking at the unilluminated portion of it, and you're looking at it at the same time that the sun is near it in the sky, and so you're not able to see anything at new moon time. About the only time you even know it's there is during a solar eclipse, when it happens to get exactly between the Earth and the sun. And then you can see the sort of covered up part of the sun. You know the moon is there, but you can't still can't see the moon. It's just a black thing against the sun. We've identified the new moon so far. The moon is going to orbit the Earth in the same direction that the Earth turns on its axis. And so that's counterclockwise from this viewpoint. So about 3 or 4 days after the new moon, the moon would be in this position with respect to the Earth and the sun. The moon would be in this position with respect to the Earth and the sun, and we would see a waxing crescent moon. And the way that appears is like this. Some things to notice about it: it is a crescent shape. Kind of looks like a smile or something if you rotate your head just right. This one happens to be illuminated on the right side as seen from Earth. And so that's an important thing. That happens to be the western side of the moon that's illuminated. All right, moving right along here, after the waxing crescent moon, we get to what's called a first quarter moon. And I mentioned that the cycle starts at the new moon. When you get down to here, where the first quarter moon happens to be, you're a quarter of the way around the cycle. And so that's what that happens to be. And that's what a first quarter moon looks like. It's just about a half circle. Again, illuminated on the right side. Okay, after the first quarter moon, now we've seen the moon grow from nothing when it's a new moon through a crescent and then a first quarter moon. By the way, that word waxing means it's growing night to night. And so it's still going to be growing. And we get over to this point and it's a waxing gibbous moon. And here's what that looks like. Illuminated on the right side again, you can see that there's stuff missing to the left of that nice big crater that's there. And it's more than a half circle, but not quite a full circle yet. And that's what we describe as a gibbous shape. It's still growing night to night, so it's waxing. The next thing that happens is a full moon. And you know what a full moon looks like? There it is. The entire portion of the moon is illuminated there. Now, from the new moon over there on the left, through the waxing crescent moon, the first quarter moon, the waxing gibbous moon, to the full moon, the portion of the illuminated portion that you saw of the moon got bigger night by night, and through that entire half cycle we saw a waxing moon. The full moon could also be called a second quarter moon. It's halfway around the cycle. We just finished the second quarter, so it's like halftime at a football game, although we don't use that term to describe the moon. Now the moon is going to begin shrinking night by night. The illuminated portion we see now is all of it. It has to shrink because we can't see more than all of the illuminated portion. And so when it's shrinking night to night, we call it waning. And at this point, the waning gibbous moon, we don't see a full moon anymore, but it's more than a half moon. And so, again, we call it that waning or that gibbous shape, more than a or less than a full moon, but more than a half moon. And it's waning. It's growing less night by night. And now it's illuminated. The left side is the part that's illuminated. That's the eastern side. So we have that happening. Fade that out. And next we get to the third quarter moon. And it looks like I didn't quite catch the third quarter moon. If I had, that day-night boundary down there would be more of a straight line. But I didn't do too bad on it. It's just a little bit past the third quarter moon. But it's just about a half circle. It's illuminated on the left side, which is the eastern side when we're looking at it and from a northern hemisphere viewpoint. Actually, everybody sees it illuminated on the eastern side. It's left for us. It's the right side for southern hemisphere observers, but don't worry about them. Okay, you can imagine what's coming next. It's going to continue to shrink. And 3 or 4 days after that waning crescent moon, we'll get to, or after that third quarter moon, we get to a waning crescent moon. And that's what it looks like. There's a few things to notice about this. For one thing, it is a crescent. It's illuminated on the left-hand side, which is the eastern side. And you can see some of the unilluminated portion of the moon. It happens to be illuminated not by direct sunlight, but by light that reflects off the surface of the earth and lights up that unilluminated portion. It's a phenomenon called earth shine, and it's neat to see. Okay, so that's the full cycle. A few things I want to point out. There are things that I call quarter, actually not just me, but other people refer to as quarter phases. That's the new moon, first quarter moon, full moon, and third quarter moons. The ones in between those are things like the waxing crescent moon, the waxing gibbous, the waning gibbous, and the waning crescent moon. If you look on most calendars, they'll tell you the dates of those quarter cycles, like the new moon, first quarter, full moon, third quarter, and they'll be in there. Not every calendar has them, but many of them do. Okay, that was back to new moon. Now let's see what we can learn about rising and setting times. I replaced my Earth with just a blue dot here, and we're going to try to figure out when these phases of the moon rise. For instance, when does a waning gibbous moon rise? That will be when an observer's eastern horizon points at the waning gibbous moon. By the way, the waning gibbous moon does not rise at 300 hours. That's when it appears high overhead. If you were to get in here, I don't know if you can see the mouse cursor or not, but the 300 hours is what points right at the waning gibbous moon, but that's when it's highest overhead. So let's see when that rises. And I'll start off with an east-west horizon that's just tangent to the Earth there, and we'll rotate it until the eastern horizon points at that waning gibbous moon. So that will happen when the observer is standing there at that point. The east-west green line is touching the Earth, and they'll be there at 2100 hours. So that waning gibbous moon rises at 2100 hours, 9 p.m. When does the waning gibbous moon set? Things set when the western horizon points at them or sweeps past them. That happens over here. Well, that's at 900 hours, 9 a.m. So it rose at 2100 hours, 9 p.m. It rises at 9 a.m. or 900 hours. Let's pick another one. When does a first quarter moon rise? Well, we just have to rotate that Earth and the green line until the eastern horizon points at that first quarter moon. Okay? The observer will be standing where that east or the green east-west line touches the Earth. They're experiencing noon. The first quarter moon rises at noon. It's the only one that rhymes. And where do you think it's going to set, or when? When does a first quarter moon set? How about 12 hours later? It rose at noon, 1200 hours. It will set at 0000 hours, midnight. You may have just a couple more of these. When does a waning crescent moon rise? Let's see, waning crescent. There it is up there. Let's rotate our Earth with its east-west line until it points at that waning crescent moon. Okay. 3 o'clock in the morning is when that waning crescent moon will rise. That's when the observer is standing there with their eastern horizon pointing at the moon. And you can guess when it will set. The waning crescent moon will set when the western horizon points at it. 1500 hours or 3 o'clock in the afternoon. I don't memorize the rising and setting times of the moon, although I've done this enough times that I can just about have them memorized so I can rattle them off. But I can quickly draw a diagram like this, and I'll show you how to do it on paper and figure them out. I use a pen to represent the east-west horizon, and I'll demonstrate that in class tomorrow probably.